Number 10 told that Superman sells storybook and textbook. The cost price of a storybook is 600 shillings, while that of a textbook is 900 shillings. The salesman is paid a commission of 10%. The cost of any book sold. One day, the salesman sold twice as many storybooks as textbooks. He earned a commission of 8,400 shillings, determine the total number of storybooks sold. Now, see that storybook, the price of a storybook is 600 shillings. And that of a textbook, the price is 900 shillings. So you are told that he paid a commission of 10% on any book sold, any book. So it can be either storybook or textbook or both. And so we're told that one day he sold twice as many storybooks as textbook. So you can say that the textbook sold, let it be X. So meaning that the storybook sold was twice. So it is 2X. Yes, now meaning that 2X is the number of storybooks sold. And then you multiply this one by the price of a storybook. So that is 600. And then plus the textbook was X textbooks times the price of one textbook, that is 900. So when add this one, I'm going to have 1,200X plus 900X. So we're going to get 2,100X. Now this one is the price or the total amount that he received from selling 2X and X books. So he was given a commission of 10%. So 10% of 2,100X, and the total amount he received was 8,400. So suppose now to find the value of X. We find the value of X, so meaning that X will be equal to 8,400 times 100 over 10 times 2,100. So take your calculator so that you're going to get 8,400 times 100. We divide by, you're going to get X is equals to 40. And this one was the textbook. He sold 40 textbooks. But the question is determine the total number of storybook sold. So remember, storybook was 2X. So meaning that storybook will be equal to 40 times 2. So he sold 80 storybooks. The next one, this is number 11. This is a question in Form 4, a topic known as area approximation. So you have the equation of a curve is given by y is equals to x squared. So you're told to use trapezium rule with 4 strips, estimate the area enclosed by the curve, the line x is equals to 1 and up to x is equals to 5, and the x-axis. Now this statement is what it means, this statement here. So you have a curve. So let me have, we have a curve here. Of course, this one is a quadratic curve. So, and then you have, maybe you can have a Cartesian plane. we have a Cartesian plane here in black. So that is our Cartesian plane. So you have the curve, this is the curve y is equals to x squared. And then we have x is equals to 1, it is here, up to x is equals to 5. So the question is, you're supposed to get this area, the whole of that area. And that's the reason we have the curve, the line x is equals to 1, it is this line here. It is known as the ordinates, and x is equals to 5. Now this one is the last ordinate, and then the x-axis. Now this one is the x-axis. So they are talking about this area. Now we need now to use trapezium rule or trapezoidal rule. So told that you need to have 4 strips. So meaning that between x is equals to 1 and x is equals to 5, supposed to have 4 strips. And the strip is the gap between the trapezium. So you have one here, and then another one somewhere here, another one. So these are 4. 1, 2, 3, 4. Now the space is known as the strip. So meaning that we need now to find the value of x here, the value of x. So for you to get that one, you need to get what is known as the height. So height is equal to the range. The range is the difference between the highest value and the lowest value. So that is 5 minus 1. And then you divide by the number of strips, 4. So you're going to find that you require a height of 1. So meaning that you have x is equals to 1. So the second ordinate, it will be at the value where x is equals to 2. And then the third one, it will be x is equals to 3, x is equals to 4. And then finally this one. So you'll have 6 strips. The space 1, 2, 3, 4. Yeah, no, you'll have 4 strips, and that is the space 1, 2, 3, 4. But then you're going to have 5 ordinates. Now ordinates are these lines. So you're going to have 1, 2, 3, 4, 5. Now, so going now to use the formula of trapezium, but the best way to do this is just have a table, a small table. You draw a small table. So you have the values of x and the values of y. The values of x and the values of y. So we have that just a small table there. So that we have x and y. Now we need y because we need the length of these ordinates. The length from here up to here, the length from here up to here, the length. Because now these are trapezium. And remember, we cannot find the area of a trapezium if you don't have the height and the sum of parallel lines. So we need the values of y so that now we have the sum of, or we have the parallel lines. So we start when x is equals to 1. The first ordinate will be at x is equals to 1. The second one will be at x is equals to 2. And then x is equals to 3, x is equals to 4, and finally x is equals to 5. So we're going to have 5 ordinates, but 4 strips. Strips is the gap between 1 and 2, 2 and 3, the gap. So we're going now to replace this one to this equation. So when x is equals to 1, the value of y is equals to 1. When x is equals to 2, so we're going to have 2 squared. So this one will be 4. When x is equals to 3, this will be 9. When x is equals to 4, this one will be 16. And when x is equals to 5, this one will be 25. Now, the next thing you need to know is the formula. Because the moment you have a wrong formula, then you're going to have a wrong answer. So the formula of trapezium rule, it is a half height. And then you have that bracket. And then you have another small bracket. You're going to add the first ordinates and the last ordinates plus twice the sum of the remaining ordinates. So you can have y1 plus y2 plus y3 up to yn minus 1. So that is the formula, and then you have that bracket. So you just need to substitute. So we're going to have area A is equal to a half times 1. Remember, this one is our height, and then you have that small bracket. So we're going to add the first ordinate. Remember, it is this value. Now this one, it is our y0, and this one, it is our yn, and then these are now at the middle ordinates. So we're going to add 1 plus 25 plus the brackets plus twice the sum of the remaining. So this one plus this plus this. So that is 4 plus 9 plus 16. And then you close it. So we're going to have a half. Of course, times 1, it is still a half. Then you have this bracket. So you must solve what is inside the bracket first before you multiply by a half. So you have to solve what is inside the bracket. So this one will be 26 plus 4 plus 9 plus 16 times 2. So that is 58. So this one will be a half times. So you add what is inside the bracket. So that is 84. So we're going to get divided by 2. So the answer is 42 square units. So, but you can leave your answer as 42. It's 42 square units, not 42 square centimeters. It's 42 square units. So that is number 11. Number 11. Number 12. Number 12 is this one here. So you are given vectors A, B, and C, and represented by this drawing. This is vectors 1 in form 2. Vectors 1 in form 2. Now we have this vector here. We have another one. The B is here, and then C is here. Now, now from this information, maybe you can get what is known as the column vectors. But for this question, you're not supposed to use the column vector. You're supposed to use the drawings. So on the question is, on the following grid, represent the resultant vector A plus B. So you are not supposed to calculate, but just need to use the drawing. So you have vector A plus vector B. And when you're talking about vector A, to represent a column vector that is 2 units to the right and 3 units up. So I can you have to draw it here, straight line. So my graph is not visible. So you have 2 units to the right and 3 units up, 1, 2, 3. So that is our vector A. And you must show with an arrow. So that is vector A, the vector notation. And then you're going to add B. And remember B, it is 2 units to the right and 0 units up or down. So it is 2, 0. So you have it here. B, vector B, it is that one up to there. Let me use a thicker line so that it is visible. So that is vector A, and then vector B. So suppose now to show the resultant, and the resultant is this one. A plus B. Going to get, you're moving from this point to here, and then it's the same as moving from this point here to here. So the arrow is this direction. And then you write A plus B with vector notations. And that's how you're supposed to draw it. Remember, in vectors, direction, you have to consider the direction. So, and then number B, the resultant vector of A plus B into brackets and then plus C. So you need to solve what is inside the bracket first. So meaning that this is our vector, this one. The one that we got from part A, we're going to use it in part B. So remember that A plus B, it is this vector here. Is this vector, and that vector, it has 1, 2, 3, 4. 1, 2, 3. It is 4 steps to the right, 3 steps up. So I'm going to draw it here. Let me use maybe a different pen. And draw it maybe here. So 4 steps, 1, 2, 3, 4. 4 steps to the right. So from here, 4 steps to the right, 1, 2, 3, 4. And then 3 steps up to here. So I have this one. Let me see if it is my space distortion. See. Okay. So I have a vector. This is my vector. A plus B. And then I'm going to add C. When you look at C up here, it is 2 steps to the left and 2 steps up. No, okay, 2 steps to the right and 2 steps down. So that is 2, -2. 2 steps to the right, 2 steps down. So from here, 2 steps to the right and then 2 steps down up to here. So I have C. And it is downwards, shown with an arrow. That is vector C. So the resultant vector, it will be this line here. And you're moving from this point to this point to here. It is the same as moving from this all the way to this one. So the direction of the arrow is this. And then you write it. So that is bracket vector A plus B plus the bracket and then plus C. So that's how I was supposed to do it. That number B.